Hey everyone, welcome back to Physics Calculus. Today I have a problem from the University of Physics textbook, adapted from problem 8.44, and this problem combines the concepts of conservation of energy and conservation of momentum. And it says a 13 kilogram block is fastened to a light horizontal spring with spring constant 400 newtons per meter. The block is on a horizontal frictionless surface. A 5 kilogram rock moving to the right at 7 meters per second collides with the block and rebounds to the left horizontally at 3 meters per second. What is the maximum compression of this spring after this collision? So let's draw a picture here. So we have our frictionless surface right here, and let me change pens real quick. We have our light horizontal spring right here, and our 13 kilogram block attached to it. And then this spring constant has a spring constant of 400 newtons per meter, so K equals 400.0 newtons per meter. And our mass of our block, which I'm going to denote M sub B, equals 13.0 kilograms. And then we have our rock moving towards this at 7 meters per second. And the mass of our rock, which I'm going to denote MR, equals 5.00 kilograms. So it wants to know the maximum compression of the spring. So if this is my positive x direction, then it wants to know this some horizontal distance x. Alright, so VI of the block here is 0 because it's initially not moving. Our VI of the rock, VIR, is going to be 7.00 meters per second. Our VF of the rock is going to be negative 3.00 meters per second because it's moving to the left at that point. And then our x distance is what we want to know. And yes, there's no mass of the spring. Okay, so and the VF of the block is some unknown value, but we're going to need to find that in order to complete this problem. Okay, so let's use our conservation laws here. So we want the compression of the spring X, and it's going to be maximally compressed when the momentary velocity of the block is 0. So when the kinetic energy of the block is 0 after the collision, then X is going to be at its maximum value. But we're going to need to use conservation of momentum laws first. We cannot combine the two because they are different quantities. So our conservation of momentum is Pi equals Pf. All the momentum initially equals all the final momentum. So we have MV of the block, so MB VIB of the block plus MR VIR, the initial momentum of the rock, equals the final momentum of these two objects, so MB VFB plus MI VF, MrVFR. And because the block is not initially moving, we know that this term is going to be 0. So plugging in our values here, we have MR 5 kilograms, so 5.00 times 7.00 equals 13.0 times 5.00, and then minus, because we have the minus 3 meters per second here, minus 5.00 times 3.00. Oh, I'm sorry. This is unknown. This is just VFB. I apologize. Okay, so isolating VFB, because that's what we need to solve for, we have 35.0 plus 15.0 equals 13.0 VFB. Okay, solving for VFB, adding these two numbers and dividing by 13, we have VFB equals 3.846 meters per second. Okay, so that's the final velocity of the block after the collision. And so now we have to switch over to our energy laws. So if we have this certain kinetic energy associated with the block given by 1/2 mv squared, well, we know that the maximum compression distance is going to be when all of the kinetic energy of the block has been converted into potential energy of the spring. So we know that all of this, 1/2 mv squared, is going to equal 1/2 kx squared, where x is what we need to find. So let's solve for x real quick. We can cancel this 1/2 on both sides, and dividing by k, and then raising all of this to the 1/2 power to cancel out the square root of x. We have x equals the square root of m VFB squared over k. Alright, now plugging in for all our values here, this equals the square root of MB, which is 13.0, times VFB squared, which is this value, so 3.846 squared, divided by k, which is 400. And punching this into our calculator, we get approximately 2.27 meters as our final compression distance for x. And this certainly is a plausible value. So this 2.27 meters is our answer. Alright, thank you guys for joining me today. I apologize that I haven't been uploading in a couple weeks, but hopefully I will be able to be more consistent in the next few weeks. Please subscribe and like this video if you found this video helpful. helpful. Or even if you didn't, if you know someone who would benefit from this video, I would appreciate it if you shared it. Thank you guys. I'll see you next week.